solving trig equations. Alright, so when we're solving trig equations, we're going to sometimes be using things from the last couple of sections with the identities to rewrite something. Sometimes it's just a function that has a trig, or an equation that has a trig function in it, and we're using those, a lot of inverse trig stuff to solve these equations. So when we get any solution, we need to check for extraneous solutions. Anybody know what an extraneous solution is?
An extra solution that doesn't work.
Yep. It's basically a solution to a problem that doesn't work. So with these, we always check the solution back into the problem. To verify they work. Some of the problems, let me see exactly how they word it. They say to find the general solution. And so if they ask us for that, we add 2n pi for sine and cosine, or n pi for tangent, to include all possible solutions, because there are infinitely many solutions. All right, I'm going to give y'all a chance to earn a cookie point here by a question that I'm about to ask you, okay? So, why would I have a general solution, say like 5 pi over 4 plus 2n pi for sine or cosine, or that plus n pi for tangent? Like, why would it be 2n pi for sine and cosine, but only n pi for tangent?
Wait, I'm gonna use this real quick.
So
Tangent.
2 pi is a full rotation, and n just says how many times it goes around, and the n pi is, it's not a full rotation, it's just a half.
Okay, but that is true, but like, why would it be different for sine and cosine versus for tangent?
Because tangent is equal to sine over cosine.
I just know that tangent looks different.
Think about your unit circle.
It's negative.
Because cosine is the x and sine is the y.
Oh, I know. Because the tangent is positive on two of the sides. So when if you just rotate 180 degrees, it's the same.
Yep. So tangent values repeat halfway around. Sine and cosine has to basically go all the way around to give you the exact same value. Answer.
We just need 5
We
more
only
guys.
have 5 points.
That's
We
because she
have a
knows
lot.
Algebra 2 really well, so she doesn't make a lot of mistakes. We're doing good better than college Algebra.
Oh, there we go.
They don't talk to me.
Yeah. I think.
I literally be like, all right, guys, let's answer this problem. And they're just like anybody? I'll sit here and wait. And then they're like, oh. I'm like, they're all just very quiet people, but it's just, yeah. I'm like, come on, guys. All right, anyways, but yes, on the unit circle, tangent values are 180 degrees apart, or pi apart, but like sine and cosine, like they're either like both on top or both on the sides. We can't just go around like a partial time, because that won't hit all the values where that is equal to that. Alright, so jumping into problems. The first ones are just checking to see if the given x value is a solution to the equation. So number 4, pi times the secant of x plus pi equals 0. And they tell us that x is equal to pi. So basically this is just the check part. We're looking essentially to see if the answer they gave us actually works or is extraneous. So if I plug in pi times the secant of pi plus pi, what is the secant of pi?
Is this one of our identities?
No, this is just from the unit circle.
I know this. Secant of pi is 0. Wait, no, that's 10. How do you find secant?
Is it
Well, what is secant? This would be like an identity.
Oh, secant is
1 over cosine.
1 over cosine, so what's 1 over the cosine of pi?
-1.
Yep, 1 over -1, so that would be -1. So this is negative pi plus pi, so 0 equals 0, so that one is a solution. Alright, 8, same thing. 3 times the cotangent to the 4th of x minus the cotangent squared of x minus 24 equals 0. X equals 7 pi over 6.
I like this a lot better than what we did on Friday.
Alright, so I take and I plug 7 pi over 6 in for x everywhere, and what I would recommend doing is I would rewrite the 3 times the cotangent to the 4th of x as cotangent of 7 pi over 6 raised to the 4th times 3, so that if there's a negative in there when I'm done, I make sure that I'm paying attention to the exponent being raised to the 4th, so that I can pay attention to that. Because a lot of times if you just plug in 7 pi over 6 and whatever, and I don't know off the top of my head, but whatever that ends up being, like, people get confused about it being raised to the 4th or being squared or whatever, okay? So what I would do is I would write this as 3 times the cotangent of 7 pi over 6 raised to the 4th minus the cotangent of 7 pi over 6 squared minus 24.
Hey.
Hello. Joining
you?
us for math today?
Hey guys,
What's up, Mason?
how you been?
Good. It's good to see you.
Good to be back. What'd you say, Chuck?
How was that?
I think they want to dye your hair, is
No,
what
no,
they
no, I
were
can't.
saying.
What math is this?
Algebra 2.
Trig. We're in the trig
Yeah,
part.
we're doing
Can you
trig
solve
right
this?
now.
What are you guys on?
Solving trig equations.
You've done this before, right?
I don't know. I'm in
You're
calc.
not giving us a lot of confidence here.
Hey.
Well. Yeah, I lost my train of thought. No, yeah, I'm
It's okay, we're
fighting
not
the
gonna
battle
either.
with calc right now, so that's fun.
It's always fun.
Yeah, I have a math tutor, and then I got the whole 9. It's a lot. But the teacher gives a lot of homework.
If you have to take calc 2, I'll pray for you.
I will. I want to go Navy, and they want everyone to be new qualified. So you have to do up to Calc 2 and up to Physics 2.
Most
then-
people drop out at calc 2, so I'll be praying for you.
Yeah, it's a lot, and you have to take. I think you have to take 2 semesters of each. So,
Probably, yeah.
I was just gonna say that.
That's a lot.
Calc 3 is easier than calc 2, though. So if you
That's
survive
what I've
calc 2
heard.
and they draft you to take calc 3, it's not that bad.
Yeah, I have a really good physics major friend, and like he
Yeah,
loves
befriend
this
those
stuff.
people.
And I'm like, yeah, I don't understand how you enjoy doing homework. That's not me. No, he
Yeah, no.
yeah, he sits down and does it for hours, and it's like that's not.
I did it for hours because I didn't understand,
Yeah,
not because I wanted to.
I'll let you get back to teaching.
Sounds good. It was good to see you, Mason.
Good to see you. I'll see you
Are
guys
you
later.
staying?
Zero.
Like,
I'm here till Sunday. I'm about to go out to the lunch with Pastor Thor.
Can I go with you?
Can you bring me something?
No, you guys have school.
Oh.
No, but like you can bring
Where
me
y'all
something.
going?
But can I go with you?
I have no clue. Wherever he decides. So, but I'll be around the week. I'll probably come back with my mom a couple
You
times.
should go to Ron's tennis practice.
Shut up.
come to my tennis.
Is there a match anytime soon?
You don't want
Next week,
Oh, okay.
not this week.
Seriously?
That's crazy.
Oh my
I
God.
think next Tuesday or
Y'all are so cool.
Already?
Thursday. Yeah.
Wait,
Yeah, I'll be going.
Tuesday.
I might be. I have to look.
Yeah, I'm
Yeah, I know
gonna.
Cash is playing. How's Cash doing with tennis?
Good.
Yeah.
Yeah.
He was talking about it. He was like, I could beat you in a 1v1.
I don't know about that.
1v1? Oh, I forgot this thing.
If you've never hit before, maybe.
I think I could still get him.
I can't play in the cold. Me, cold plus tennis do not.
Zach went
work
like
with me.
4 for 25 on the serves.
That's why I don't like warming. I don't like playing next to the wherever we are. The
Water?
yes, it's so cold.
Alright. Lock it up.
Lock it
Yeah.
up.
I'll see you guys later.
Push-ups.
Shit saluted him by. He could have just said 0 equals 0 and he would have solved the thing. He's gonna say he missed that opportunity. That's the answer. Oh, it's what we're ultimately.
We're not done. Okay. So, cotangent as an identity would be equivalent to what?
1 over
Wait.
1 over tangent. Okay. So,
Wait.
I'm going to do a little like intermission pause here to just figure out what the cotangent of 7 pi over 6 is.
Can cotangent also be cosine over sine?
Yes, but we shouldn't do that in this case.
Oh.
We only do it that way if we're trying to cancel stuff. So, this would be the same as 1 over the tangent of 7 pi over 6. So, what is the tangent of 7 pi over 6? So, this is 1 over root 3 over 3, or 3 over root 3, which is what?
Square root of 3, square root of 3 over 3.
3 root 3 over 3, or just root 3. Okay, so all this little intermission was to solve what's in this parentheses here. Okay.
Oh my goodness.
So now I'm picking it back up. 3 times the square root of 3 raised to the 4th minus the square root of 3 squared minus 24 equals 0.
Can I ask a question?
Yes.
I'm sure this is really obvious, but why isn't the square? Why isn't 3 over the square root of 3 root square root of 3 over?
Because
It is. I canceled the 3s.
Okay.
Yeah, sorry.
I had to say it to understand.
Nope, yep, you're good. Normally, well, sometimes I would write it.
9 minus
When I'm
3
just
is-
doing it for myself, I don't, and I just didn't write that intermediate step. But yes, it would have been.
Okay.
All right, so what is the square root of 3 to the 4th?
9.
So this is 3 times 9, which is
9. 27.
27, minus the square root of 3 squared,
3.
minus 24. So 0 equals 0. So this one also worked.
Wow, that was amazing.
Oh, you did 9 times 3 in the same thing. That's why.
Now, these problems are verifying both of ours happen to work, but don't just assume that it's automatically going to work. Okay? They may or they may not. So make sure you're paying attention to that as you're doing those ones. All right, the next ones say to find the general solution. Okay, the other option, because you obviously don't know what that is they'll tell you that your solution is between 0 and 2 pi. And so we would only have the exact value that we're given. But with the general, that's where we'll be adding the 2 n pi or just n pi, depending on which trig function we are given. All right, so number 10, square root of 3 times the cosecant of x plus 2 equals 0.
It's really fun writing these problems out, but I don't like actually solving.
All right, so now we're we're solving for x. So stuff that we've done before, but now we're doing it in terms of trig functions. So if I want to get x by itself, what do I need to do?
Divide it
Divide by cosecant
Divide by 3.
I can't divide by
Put
cosecant.
2
2
to the
over
right.
first.
I need to subtract the 2 first. So I have the square root of 3 cosecant of x is equal to negative 2. And obviously, as you get more familiar, you don't have to do all of this little step by step. You can do like what we're about to do. You could have done this all in one step. What would be next?
Divide by negative 3. I mean, square root of 3.
Divide by square root of 3. So cosecant of x is equal to negative 2 over the square root of 3.
You can't have to do that.
So you gotta multiply by root
It's
3.
1 over.
Don't do that yet.
Well, okay.
What were you about to say?
It's 1 over the inverse sign of negative 2 over root 3.
'Cause you
Not
want
1 over the inverse
of
sign,
x.
just 1 over sign.
So sine. of
1 over,
x.
listen, cosecant is 1 over sine. So this is 1 over the sine of x is equal to negative 2 over the square root of 3. Now, both of these are fractions. I flip the fraction over. So this is sine of x is equal to root 3 over 2, and that whole thing is negative. Now I can take the inverse.
Okay.
I can't take the inverse up here.
Okay.
That has to be like the last thing that we do. Like it was when we did law of sines.
So there's no inverse cosecant.
No. I mean, yes and no, but there's no button for it. And that's not a value that you would just know.
Yeah.
We needed everything in terms of sine, cosine, tangent.
Third sine is y.
Oh, it's when it's
Everything needs to be rewritten as sine, cosine, or tangent because that's what we have the formulas for to do the general stuff.
4 pi.
So now we take the inverse sine.
But sine is 1. Yeah, sine is 1.
So 4 pi over 3.
2/4 degrees over 4 pi.
Four
Now,
squared.
this is where you're probably going to get a little bit confused. Okay, and I used to teach this, and then it got people really confused, so then I stopped. When we do inverse trig, what was true about our values? But let's say specifically sine. Where did inverse sine occur?
On the
First.
x-axis.
First and second slide.
First and
Yeah.
Yes.
Well, 1 and 4.
Yeah.
Well, yeah.
The right side. So,
What is this?
that is, this is why you're going to get confused a little bit. That's not true when we're solving trig equations.
So
Okay.
just forget everything that we just learned.
Well,
about.
don't forget that. They're like two different things, okay? Because I used to teach that, and then I was like, but then people were forgetting the second number. So just disregard that. When we're doing this, we're looking for, on our unit circle, where are the two places, or I mean, obviously some of them only have one, they're on an axis, but where are the two places that sine is equal to negative root 3 over 2?
Last, third quadrant.
4 pi over 3 and 5 pi over 3.
4 pi over 3 and 5 pi over 3. Okay, because they're both on the bottom.
Oops, I did 4 times pi over 3.
So 4 pi over 3 and 5 pi over 3 both have a y value of negative root 3 over 2.
Yes.
Okay? So to get back around to both of those, I have to add 2 in pi. So plus 2 in pi on both of these. And I can go around as many times as I want, and that will continually give me a solution that meets this. So, a lot of these problems will have 2 answers. Some may have 4. Some may only have 1. Okay? So, make sure you're looking, is there anywhere else on my unit circle that it meets these values? Okay, as I'm going one time around. Then after that, it's adding the 2 in pi on the general solution.
Will we ever be finding like the degree of these solutions?
No, we only use radians.
So, are we supposed to put this number back into the problem and check it?
On the,
Check for extraneous solutions.
No, only on the ones that are specific solutions.
Okay.
Yeah.
I was gonna say I don't know how to put that back in the equation.
No, it's only the ones that are specific. So if this wasn't a general solution problem, we would just plug in 4 pi over 3 and 5 pi over 3 just to verify that they both work. Because sometimes one of them, predominantly if they're something that's being squared or something, it may not give you the right answer. All right, next one, number 12. Let's see, sine of x plus the square root of 2 equals negative sine of x.
Why did you write so big? Why do you have not college ruled paper?
Okay, sine of x plus root 2. Move, wait, which one do you want to
Minusing square root of 2.
All right, so it doesn't really matter what direction or what side the trig function is on, because it's something that's an equal sign. So I need to get all of the, basically your goal is we're ultimately solving for whatever our variable is. I think in all of these they use x. I don't think any of these use theta. So for x in this section. But the first thing that you need to do is get the trig functions on the side by themselves. Okay, so since I already have a root 2 over here and I have a sign on both sides, I would move this sign over because otherwise I'm moving a bunch of stuff all around. Okay, so this is going to be the square root of 2 equals, subtract sine of x. That's, yep, negative 2 sine of x. Now, if you want the trig function on the left, you can invert this and put the sine of x on the left and the square root of 2 part on the right. Totally up to you. Okay? Now, how do I get sine of x by itself?
Divide by 2.
Divide.
Negative 2.
Divide by negative 2. So I like my trig function on the left, so I'm going to put it over here. So the square root of 2 over negative 2. So now, I'm taking the inverse sine of root 2 over negative 2, or negative root 2 over 2. It doesn't matter where the negative goes. So where on my unit circle is sine negative root 2 over 2?
1 and negative 1.
Wait,
Quadrant.
I mean,
2.
5 pi over 4.
quadrant
And
3
7
and
pi
4.
over 4.
Quadrant
5
3
pi over 4
Looking for quadrants.
and 7 pi over 4. I'm looking for numbers.
30.
Now, these are sines, so what am I adding?
2 pi and 2 n pi. What is n?
It's how many times around we would go. So n is any number, essentially,
Okay.
from 1 to
If it
infinity.
were tangent, it's just plus
N pi.
Okay.
And if you're like the person that wants the numbers in front and you want to write 2 pi n, it's the same thing. They just always write 2 n pi for whatever reason. I think it just sounds cooler, but like, I don't think there's like any other reason that it's written in that order.
I like 2 pi.
All right, number 14. This one is a tangent one, so that's good. 3 times the tangent squared of x minus 9 equals 0. So I want to get that tangent of x basically by itself. So what would I do?
Move.
Make it squared, like make the whole thing squared, right? And then
Plus
move the
9.
9 over.
You could just make
I'm not going to with this one because I'm not plugging the number in. But yes, you could.
Okay.
Most of the time, I don't rewrite it. I'm mainly rewriting it up here when we're plugging the number in so that we don't get confused.
Yo, this makes more sense than what we did on Friday.
Yeah.
So
So move
over
the
and
9.
divide by 3.
Yep, so 3 tangent squared of x equals 9. And again, you could do this in one step. Tangent squared of x then is equal to 3. Now,
Tangent equals.
obviously, kind of what, Daniel said to rewrite it as a tangent of x squared. You don't have to do that, okay? You can if you want to, if you like that visual. But when we have something squared, how do we undo it?
Square root.
And when we're solving an equation, what happens?
We are don't care.
We do it on both sides.
I know my mom emphasized this to you. When you take the square root, what happens?
It flips.
What's your answer?
Root 3.
Negative
Positive or
answers.
negative?
Positive or negative. Okay? So the tangent of x is equal to plus or minus the square root of 3. So, where is tangent? We take the inverse tangent, and you need to write these as separate once we do this. So the inverse tangent of the square root of 3, or the inverse tangent of negative square root of 3. Where is the is tangent positive root 3?
1, 2, 3, 4. I mean, wait. Tangent. What is that? Pi over 6? No, it's
Pi over 3.
Pi over 3.
And
Okay, this occurs at pi over 3. It also occurs at 4 pi over 3.
There's 4.
I'll just hold right there. We're not adding anything yet. What about this one? Where is it negative root 3?
The mirrored side.
5 pi over 3 and 5 pi over 6.
2 pi over 3 and 5 pi over 3. Now, when I'm doing the general solution, we choose the first one that we come to, and then we add the n pi. So the first one on the unit circle that I come to for this one is pi over 3. So I'm ignoring the 4 pi over 3, because when I add n pi, if I add 1 n pi, okay, or like 1 n, so 1 pi, then that would get me to 4 pi over 3. If I add another pi, that's going to put me back around again, okay? Over here, this one, 2 pi over 3 is the first thing I come to. If I add pi, it puts me at 5 pi over 3. So this would be 2 pi over 3 plus n pi. So I'm ignoring the second one that I came to. Normally, I wouldn't even write the second one. I'd only write the very first one, but I just wanted us to see it.
So what if I solve 4 pi over 3 first? Would that change anything?
Well, that's not the first one that you come to, so that shouldn't be the case.
What do you mean by, like, how do you know it's the first one you come to?
Starting on X, right? And going up.
Starting and going around, the very first one that I come to is pi over 3.
Okay, I thought I was just searching for
That is the
Should always go around in order. Now, if this was a specific solution problem, which is what we're moving into, then we would have needed all 4, which is why I said sometimes they have 4 answers. Okay? Because this one at each of these values would have been in the 0 to 2 pi range that it was asking us for. But these are just general, so it's the first one that we come to. Let's see. The next one, say to solve on the interval 0 less than or equal to x less than 2 pi. So notice they're not wanting us to go all the way to 2 pi, it's just up to 2 pi. So this interval is very important to pay attention to. All right, number 16. 5 plus 2 sine x minus 7 equals 0. And on these problems, this is where we have to check because it's a specific solution, and sometimes an answer that we get may not actually work when we plug it back into the problem. That typically happens more so when there's multiple numbers or something like being squared. It doesn't always cancel out, which is why we have to check them. So the goal is still, it gets solved down the same way, it's just our final answer is different. So what would I do first here?
minus plus 7. I mean,
So
plus
you
12.
5 and 7. So it's
Okay, so
negative
5
2.
minus 7 is what?
Negative 2.
So I'm going to add 2 over, right?
2 sine x equals 2.
Yes.
Divide by 2.
So sine of x equals 1. So where is the sine of x 1?
Nowhere. It's always 1/2.
Not in this. Oh, wait. Oh, why?
It's on
I mean, pi over 2.
At pi over 2. So that would be my answer, but I need to check it. I should say x equals that. So I check by plugging it back in. So 5 plus 2 times the sine of pi over 2 minus 7. So 5 plus 2 times the sine of pi over 2 is 1. Minus 7. 7 minus 7, so 0 equals 0. So that is in fact a solution on this one.
Pi over 2 equals cosine pi over 2. So 5 plus
18. 3 cosine of x equals cosine of x minus 1. What would I need to do first?
You move all the cosines to one side, and it cancels out and equals. No, it doesn't.
So subtract this one would give me 2 cosine of x equals negative 1. Now what?
3. Divide by 2.
So cosine of x equals negative 1/2. Take the inverse. So where's cosine negative 1/2?
Second quadrant, which would be, where is that? Right. That's 5 pi over, no,
Cosine.
cosine would be x, so it would be 3, I think there's 2, 3,
Negative square root
These are angle values.
It's
Okay, so
135 degrees, but I don't know
5,
the
right?
degree value.
it's 5 pi over
So
6.
when x is,
No, it should be 120 degrees.
we're looking at 2 pi over 3.
Yes, 2 pi over 3. What else?
And 4 pi over 3.
2 pi over 3 and 4 pi over 3. These are the two spots that it is equal to negative 1/2. Now, I have to plug them in. When I do that, just like when we were verifying the other day, we only touch the left side and we only touch the right side. We don't move things left to right. We have to leave it as it is. That can also be what makes it a false statement. So, 3 times the cosine of 2 pi over 3 equals the cosine of 2 pi over 3 minus 1. So this is 3 times the cosine of 2 pi over 3 is negative 1/2. So this gives me negative 3/2 is equal to negative 3/2. So that one's good. And because I know that the cosine of 4 pi over 3 is the exact same thing, I don't need to also check that one in this case.
I don't know if this is like a cookie point or if it's just like notation error, but on the one above the answer, like I'm a little confused on the parentheses.
How does
Oh.
negative 1/2 times negative 1 equals negative?
It's not times,
Oh,
it's minus.
Okay, thank you.
Hey, wait, what was I gonna say? Oh yeah, why did they make calculators if you can't just use them to solve these?
Because calculators can't solve everything for you.
I bet they can.
Yeah, try put it in it.
Put it in. I don't know if it's gonna work.
3 cosine x alpha.
Oh wait, I have to put in the solver.
What are you talking about?
There's something that says solve, and I think it's what I have to use.
20. 5 tangent squared of x minus 15 equals 0. So what do I do?
Plus 15 divided by 5, which is negative 3. On the regular 3.
So tangent squared of x equals 3. Just doing everything in one step. Now what?
Reverse tangent. Wait, no, square root. Square root.
So I get what?
Tangent equals root
plus or minus root.
Oh yeah.
Plus or minus root 3. So where does that happen? And I don't always rewrite it as the inverse because I'm just looking for where it occurs that way. So if you want to write it that way, you don't want to write it that way.
There's 4 places, but there's 4 places, but it's pi over 3 and then 2 pi over 3 are the first ones. Yeah.
Where else?
4 pi over 3 and then 5 pi over 3.
And just for the sake of time, I'm not going to check those. They all do work.
Yay.
Let's.
They just scared so I'm Okay, so we have
Pi, Caesar.
3.
Caesar sound. Yeah, that's easier. You know why?
Why?
All right, this is back to general 26. 2 sine cubed of x equals sine of x. Any ideas if I have something like this, what I might need to do?
Set equal to
Divide,
0.
no.
Okay, how do I do that?
You minus sine x, which is 2 sine squared x.
No.
It's just sine.
2 sine cubed of x minus sine of x.
Why?
You can't subtract a cube and a non-cube.
I don't know why.
Because they're
Because
not-
you can't subtract x from x squared. Same thing.
Yeah.
They're not.
Any ideas what I need to do now?
Divide by 2.
Can't do that.
We could take.
Take out a sign.
Oh.
So sine of x times 2 sine squared of x minus 1.
Oh, we can't
What?
Oh.
So now, just like back when we were factoring and I was using my zero product property, same thing here. Sine of x equals 0, or 2 sine squared of x minus 1 equals 0. So where is sine 0?
Sine is 0
On the
at
x and y,
0
which
and
is-
pi.
At 0 and pi. I'll come back to that in a minute because these are supposed to be general solution problems. Then over here, sine squared of x equals 1/2. Take the square root of both sides. Sine of x equals the square root of 1/2, and it's plus or minus still.
That is,
What happens over here? It's not on the unit circle yet.
Plus
Oh,
or
plus or
minus
minus 2.
root 2 over 2.
Yep, so this is the same thing as the square root of 1 over the square root of 2, which is just 1 over the square root of 2. Rationalize it is going to give us root 2 over 2. So now I'm looking at sine of x equals plus or minus root 2 over, that was a really big square root, root 2 over 2. Where is sine, positive or negative, root 2 over 2? And these are general, so I only need the first time it occurs.
Oh, then it would be
Pi over 4, and where else? Three pi over 4. Nope. That's still another positive one. 5 pi over 4. There we go. So now, what?
Cat eater.
Zach, I'm trying to write this stuff down.
Oh. All right, hold on. I forgot about a different notation. There's there's other things that I need to add in here. All right, what were the other places where this occurred?
Pi over 4. Shoot.
This one's just different. That's why these are grouped differently. All right, so first of all, I'm going to go back to the sine of x equal to 0. So that particular problem, okay, how far is it to get from 0 to pi?
0. Pi.
Pi. So every increment of pi, sine is 0. Would you agree?
Maybe.
If I understood
Okay, so to get
Oh, she's right.
from here to here is pi,
Yeah.
here to here is pi, here to here is pi, here to here is pi. Okay?
Yeah.
So I just need this first one, and I'm going to do in increments of n pi. So this one is not following the rule because these are a different kind of equation. Okay, so the general solution here, one of them, would be 0 plus n pi.
So just n pi.
Plus n pi.
You have to have this.
0 plus n pi.
Why can't they just put n pi instead of just?
Because you wouldn't know where the starting point is. You have to have a starting point.
Oh.
Now, over here, the reason I said we need to go back and do this one is because there's, again, notation. It's going to be a little different because of the kind of problem this is. So, at pi over 4, a solution by just going halfway around is still one of the solutions that I have, right?
Yes.
Since I can have the positive or negative one. So I can do pi over 4 plus n pi, and that puts me here. Okay? So pi over 4 plus n pi. Then the next one that I would have come to was 3 pi over 4. Even though that one's still positive, that's another solution. I can add n pi, and that puts me over here at 7 pi over 4, which is also a solution. Okay? So this is just to be able to write it simpler than basically having to write each one of them plus 2 n pi. I can choose 2 of them and do it as n pi. Okay? So this would be 3 pi over 4 plus n pi. Now, I don't usually choose one of these harder ones on the quiz and the test. Usually I choose the easier ones for the general, but I want you to see it in terms of starting to solve them.
Since it is sine, shouldn't it be 2 n pi?
Did you ignore everything that I just said?
Maybe.
Clearly. Does somebody want to explain to him why it's just n pi?
That's how it's written, Mason. And if you look at the very beginning for the general solution,
follow the rule.
you put that. And she put
But
it-
why does it not follow the rule? Somebody had to have been paying
Because of the
attention.
Look
Notation
at the
is a
unit
problem.
circle.
Yes, because of the unit circle. All right, problems, and these are obviously homework because there's not time. Tomorrow we'll review for your test on Wednesday.
This will be.
Is this on the test?
Yes.
Okay.
Wait, don't we have a quiz tomorrow for the cheat sheet?
Yeah.
Yes.
Wait, what cheat sheet?
The
Identities.
Identities?
Yeah.
All right, 3, 5, 9, 11, 13, 17, 19, 21, and 25. Yes, your identities cheat sheet quiz thing is tomorrow at the beginning, and then we'll spend the rest of the time reviewing. And then your test is on Wednesday.